afternoon, children. Welcome to today's class. Today we are going to revise chapter 1, that is matter. So let's begin our today's class. So chapter 1 we will revise today, where the definition of matter will be there, characteristics of matter, diffusion, we will discuss diffusion, Brownian motion, states of matter we will be discussing, kinetic theory of matter, and explanation of states of matter based on kinetic theory. These are our points to be discussed today. So what is matter? Matter is anything which has mass, occupies space, and can be perceived by our senses. This you know all. So here you can see different kind of matter. It's a pumpkin. This matter can be solid, liquid, or gas. So pumpkin, magnet, log, wooden log, ice cube, all these are solid matter we will see. Okay, so all this matter in the first row, you know, all these occupy space and can be perceived by our senses, and all have some mass, definite mass. Liquid, water, milk, rain, juice, these are the liquid matter we will say. Smoke, air, wind, and steam, these are gaseous matter. Okay, so these are some example of matter. So what are the characteristics of matter? Matter consists of very small particles. So particles of matter are very small. Okay, particles of matter have interparticular space between them. In between the particles of matter there are some space which is called intermolecular space also. Particles of matter are in constant random motion. Always there will be some motion in between the particles of matter, and particles of matter attract each other. So these are the characteristics of matter. Now we will discuss the term diffusion. What is this? Diffusion is the intermixing of two or more substances due to the motion of their particles in order to get a uniform mixture is called diffusion. So this is a kind of random motion we will see. Because of the random motion of the particles, to get a uniform mixture, the particles of two or more substances, there will be a intermixing of the particles of two or more substances. Okay, so diffusion we will see generally in gases and in liquid. Okay, in solid we will not see this because the solid particles are having more intermolecular or interparticular force of attraction. Now this diffusion process can be seen. We can do a very simple experiment with bromine gas and air. Here we have taken a gas jar filled with air. That means this is empty gas jar actually, but it is filled with air. So here 100% air is there, and in this gas jar, here it is full of bromine gas. Bromine gas is reddish brown. Its color is reddish brown. So in this gas jar, the first gas jar, there is bromine gas filled with bromine gas, and here empty gas jar, that means the gas jar filled with 100% air. Now in between these two gas jars we have placed a glass plate. Okay, now if we slowly remove the glass plate, after certain time we will see the whole there will be intermixing between the in between the two gases there will be intermixing of the particles. That means the particles of air and particles of bromine. Now after some time we will see the color of the bromine that fades, because the particles of bromine, they have spread in this first gas jar as well, and the particles of air has been spread in this gas jar. Okay, so there will be a intermixing of the particles of air and bromine both. So here 50% air and 50% bromine is there in this gas jar, and here also 50% air and 50% bromine is there, where the glass plate has been removed. Okay, so this phenomenon is called diffusion. This Brownian motion, this is another motion of, we will see, motion of the particles. This is another proof of the particles, motion of the particles. Okay, so what is this? The scientist who first noticed this, Robert Brown, for his name, the motion, this motion has been called, this motion is called Brownian motion. Okay, because of he has invented, or actually rather he has noticed this motion first. So what is Brownian motion? The haphazard random motion of suspended particles on the surface of a liquid or in air is called Brownian motion. So there will be a haphazard motion between the particles. This motion is also called zigzag motion. Okay, you can see this is the particle. Suppose one particle will be considered. So this is the particle, the position of the particle is this at first, then it will move in this manner. Okay, so it's a zigzag or random motion we will see. So this random motion is called Brownian motion or Brownian movement. So this can be seen in the particles. State of matter, there are generally actually 5 states are there, but now we will be discussing the 3 states of matter, that is solid, liquid and gas. Other 2 states of matter are plasma and Bose-Einstein concentrate. So now we will be discussing these 3: solid, liquid and gas. Solid state, here you will see the particles are closely spaced. Particles of matter are closely spaced. There are very less intermolecular space in between them. See, this is the interparticular space or intermolecular space. So in solid, as the particles as the molecules of matter, these are very closely spaced, so there will be a definite shape of the matter. Okay, whereas for liquid there will be little bit gap between them. The particles are not as much closely packed as in solid, so there will be no such definite shape of the liquid. Okay, and the force of attraction in the particles of matter, they attract each other with a force which is called interparticular force of attraction or intermolecular force of attraction. So this force of attraction is maximum in solid, and then in liquid the force will be a little bit less. That's why the particles having space in between them. And in gases, even the particles are the interparticular space is much more than the compared to liquid and solid. So there will be maximum intermolecular space in between the particles, because there are least intermolecular force of attraction or least interparticular force of attraction in the gases. Kinetic theory of matter. So there's all these properties of matter, or all these phenomenon, we will say. This can be given as kinetic theory of matter. So this kinetic, this term is related to motion. So what are the main postulates or what are the main points of this theory? Matter is composed of very small particles called atoms and molecules. We know about atoms and molecules. These are the atoms, and in each and every particle, in each and every matter, we will get the least or the smallest particle, we will say, that is called atom or molecule. Okay, for elements we will get the atoms, and for compounds we will get the molecules, that is the smallest particle. So matter is composed of very small particles called atoms and molecules. This is the first point. The constituent particles of a kind of matter are identical in all respects. The constituent particles of a kind of matter, suppose if we take a piece of gold, then all the particles, all the constituent particles of that piece of gold is identical in all respects. Their shape, size, and then properties, everything will be same for that particular matters. So gold particles will be identical in all respects. If we take a piece of crystal of salt, say, then all the particles, all the particles of the salt, that is sodium chloride, you know now. So this all the particles of the salt is identical in all respects. Okay, so the second point we can say in this manner, as the constituent particles of kind of matter are identical in all respects. Their properties, their shape and size, everything will be identical for a particular matter, for a particular kind of matter. Next, third point, these particles have spaces or gaps between them, which is known as interparticular or intermolecular space. So as we have seen, in the particles or in the molecules or in the atoms of matter, there are some gaps between them, which is known as interparticular or intermolecular space. There exists a force of attraction. Fourth point, there exists a force of attraction between the particles of matter which holds them together. Because of the force of attraction, the particles of matter or the molecules of the matter, they hold them together. Okay, they will be together because of the force of attraction. This force of attraction is known as interparticular or intermolecular force of attraction. So because of the force of attraction, the matter or the particles of matter exist, or the particle of matter they hold them together. Okay, they are together. Next, particles of matter are always in a state of random motion and possess kinetic energy. Because of the random motion, they are having some kinetic energy. This kinetic energy, in physics you have read that. So kinetic, this term is related to motion. Okay, so because of the motion, because of the random motion of the particles, there will be some kinetic energy. They possess some kinetic energy, and this kinetic energy will increase with an increase in temperature, and it will decrease in temperature. So as by with increasing temperature, the motion of the particles will increase, so their kinetic energy will increase, and if we decrease the temperature, the motion will decrease, and at the same time the kinetic energy will decrease. Now we can discuss the states of matter or their the arrangement of the particles on base of kinetic theory. So for solid particles, for solid matter, we will see as intermolecular force of attraction is more or most here, so the particles will be arranged in a very closely packed manner, which will give them a definite shape. So for solid we will see there is a definite shape for all the solids, okay, and the gaps, as they are closely packed, so the gaps in between the particles or the intermolecular space or interparticular space is least in case of solid. And as the solid interparticular space intermolecular force of attraction is maximum here, so random motion of the particles, that will be least in case of solid. So for solid, the kinetic energy will be least, as the particles, the movement of the particle is least here, okay. Now come to the liquid. Because of this, all this this intermolecular space and intermolecular force of attraction, because of their least intermolecular space and highest intermolecular force of attraction, so solid is having a definite shape, definite volume, and there will be this for solid particles, for solid matter, there will be, it will not show any diffusion and all, okay. There will be the random motion is least, we will say, okay. And as the particles are closely packed, interparticular space is least, so a solid is, its density is maximum. These are dense in comparison with liquid and gases. So solid are more denser than the liquid and gases. Now for liquid, the intermolecular space is more than the solid, and interparticular force of attraction is less than the solid, so there will be a gap between them, and that's why there will be no definite shape and size for the liquid, but they are having some definite volume, okay. And because of this, the liquid, the shape of the liquid depends on the container where it is kept. So it can take any shape of the in whichever container we will keep the liquid, it will take the shape of that container. Now as interparticular space is less here, interparticular space is more than the solid, so there will be, it is less denser in comparison with solid, okay. Solid are maximum, the density of the solid is maximum, whereas for liquid it is little bit less. And here we can see the diffusion, okay. As the interparticular space is as intermolecular force of attraction is less, so there will be diffusion for liquid, they can move, okay. The random motion will be there. Now for gases, as here you can see the intermolecular force of attraction is least here, so the particles are moving here and there, and they will occupy the whole container, whole volume of the container, okay. They will be scattered here and there. That's why gases, any gas, it can be kept in any container, okay. Its volume can be compressed, okay. That means in a very less space we can fit these particles of gases, because they are compressible. If we apply pressure, these particles will come closer and can be kept in a less space. So these are not rigid, whereas for solid and liquid we will see these are rigid. We cannot change the shape of solid easily because of the less or least interparticular space, interparticular gap between them. Okay. Now gases, they are having no definite shape and no definite volume. They will occupy the whole space of the whatever volume will be given to them, whatever volume will be offered to them, they will be they will be occupying all the volume of that container, because the particles are having random motion always. Okay, and this random motion is maximum in case of gases. So there will be no definite shape. And for gases, the density is least, as there are a lot of intermolecular space between them, so density is least in case of gases. And this diffusion, we can see maximum in gases because there are least interparticular force of attraction. So the attraction in between the particles is least. That's why they can scatter here and there, and they will show the diffusion as well as Brownian motion. So this is our children, for today this will be up to this we have discussed today, and next day we will be doing the second part of this, or rest of the portion which is there. So till then you just revise this chapter. The study material will be provided with this, that you go through properly, and we will be discussing some important question answer also regarding this chapter. Okay, so till then just stay safe, take care, and keep studying.